Okay, here we go. So this is section 2.6, titled Draw Scatter Plots and Best Fitting Lines. So our goal here is to fit lines to data in scatter plots. Scatter plot definition. The first definition we see here is a graph of a set of data pairs, x comma y. Positive correlation, the relationship between paired data when y tends to increase as x increases. Positive, think of positive slope line. Negative correlation is the relationship between paired data when y tends to decrease as x increases. Got my pen ready. And finally, or not finally, excuse me, two more to go. Correlation coefficient, a number, usually denoted by R, from -1 to +1 that measures how well a line fits a set of data x and y. And finally, the best fitting line, a line that lies as close as possible to all the data points. So here we go. I wonder if I can get this out of here. Wow, nice. All right, example 1. So example 1, for each scatter plot, describe the correlation shown and tell whether the correlation coefficient is closest to -1, -0.5, 0, 0.5, or 1. So those are your only choices. Again, remember that R could be anywhere from 1 to -1. And for graph A here, we see our here's graph A. Our scatter point, and again, if we were to put a best fit line, something like that, maybe I was a little too low. We're definitely getting negative correlation, and we have a pretty good fit, so we are going to choose that scatter plot A has a negative. Oops. Get back down here. A negative correlation, and that the best estimate here, I'm going to go for -1. And then scatter plot B here, you can see that the data, if I were to kind of draw a line through, would have a positive slope line, so that we say that it has a positive. Apologize, I'm getting used to writing with this pen, and my handwriting is terrible. And here R is between 0 and 1, but not too close to either one. So the best estimate we're going to say here is 0.5. Again, somewhere between 0 and 1. That's our only choices. And so approximating a best fit line. Step 1, we draw a line through the data. Sorry. Start over. We draw a scatter plot. Of the data. Then we sketch the line that appears to follow most closely the trend given by the data points. Again, that's tricky. Saw that with the spaghetti lab, trying to fit your ruler to best, put all the points on one line. There should be about as many points above the line as below. And then we should choose 2 points on the line and estimate the coordinates of each point. And finally, we should write the equation. Of the line that passes through the points. Great. Let's try it. So again, here's a bunch of data, the table. Again, similar to what we did with the spaghetti lab with some more data. It shows the number of people is represented by the variable y, who attended each of the first 7 football games X of the season. And then we'd like to approximate a fitted line. Again, step 1 says draw a scatter plot. And here we go. Oh, come on, pen. Dropped down a little bit. Game 5, they lost some players or had a lower attendance. All right, so I plotted all 7 points as best I could on this little little graph. Again, you would then sketch the best fit line. Choose 2 points on the line for the scatter plot as shown. So chose 1 comma. Oops. Stop. Oh. Did not want to do that. At 1722 and at 2750. And now we're going to write equation through that. 750, we need the slope over 2 minus 1. It looks like we get a slope of 28. Using equation of line here, we're going to say we use the first point 722, slope of 28, x minus 1 and finally equation of a line cleaned up would be 28x plus 694. So example 3 here says use the equation of a line the best fit from example 2 to predict the number of people that will attend the 10th football game. Because you are predicting the 10th game, substitute 10 in for x. And here we will plug in into our equation. And we solve that in 10 games we should have 974 people attend. All right, go ahead and see if you can do these now on your own. Again, for the first scatter plot, tell whether the data is positive correlation or negative. And then if you could use one of only these 5 numbers to predict what the correlation coefficient is. And then here, take this data and see if you can't plot it and come up with the equation of a line. I'll give you a second here once you hit pause. So finish up, I think you should find positive correlation for 1 And I would say that the R value here is 1. And then for problem 2, actually, we don't see any. We see, of our choices, definitely not positive correlation, not negative, so we're going to have to choose no correlation here. And that would give you an R value of 0. And finally, you should have come up with an equation for B to be 1.3x plus 82.1. And then if you plug 9 in for x, you should get about 94.